Hi guys, it's Mrs. Warner, and this is my exciting Saturday night. I'm going to teach us lesson 8 on density. Does not get any more exciting, trust me, folks. Okay, here we are, COVID week, I don't know, 6, whatever it is. And here's our last little lesson for the week. We're only doing one lesson this week on density, which you guys should be amazing at because I think you did it in science last year. So we've used the density formula once in a question before. Density is equal to mass divided by volume. M stands for mass and V stands for volume. And in case you need to, you can refer to the little chart on the other side there. So let's start it. Okay, so a square metal plate has a density of 10.2 grams per centimeter cubed, and it weighs 2.193 kilograms. Oh dear. I see some units that are not matching, and that's not good. So we're going to have to convert those first. It says calculate the volume of the plate. Okay. So its density is in grams per centimeter cubed, and it's giving me its weight in kilograms. So that's not very good. So I've got to take that 2.193 kilograms and convert it into grams so that the units match. See that there at the end? So to do that conversion, I just simply times it by 1,000. Or in this case, I'm going to move the decimal point over 3 places. So if I use D equals M divided by V, I know my density is 10.2. And then my mass, which is what I just had to change over, is now 2.193. And I'm going to divide that by the volume. I can just solve for the volume by putting this over 1 and cross multiplying. So 10.2V is equal to 2.193, or in other words, my volume is around 215. Very exciting. That was fun. Okay, now it says if the base of this plate has an area of 25 centimeters cubed, determine its thickness. Oh, I didn't mean to do that. That's crazy. I didn't mean to write that over there. Okay, so it says it has an area, and I know its volume. So I know volume is big B times H, and the H in this case would be like the thickness of the plate. And I know its volume is 215. And if I take 215 and I know it has this 25 centimeters cubed or squared for its area of its base, then whatever I take and multiply the height by, if I divide it by 25 on the other side, it tells me the height is 8.6, and that's 8.6 centimeters, and that is actually the thickness of that plate. That was kind of fun. Let's try another one because these are so exciting. Okay, so a cylindrical metal cup full of water has a mass of 1,000 grams. The cup 214.6 grams. And if the cup has both a diameter and a height of 10 centimeters, what is the approximate density of water? Now, you guys are geniuses, and you should already know what the density of water is. The density of water is around what? That's right, folks, 1. So if we don't come out with an answer of approximately 1 for this, then we've done something wrong. And this is a Regents question. So you could double check yourself with that if you were a genius and knew what the density of water was. Okay, so I've got a cylinder, and I just like to draw a visual. Look at that great drawing. So this is 5 because its diameter was 10, so its radius is 5, and this is 10. Okay, now I know that volume of a cylinder is going to be pi r squared h, right? So pi times 5 squared times 10, or 25 times 10, or 250 pi. Great. I'm going to kind of leave it like that for right now, just because. Okay, now the full metal cup of water has a mass of 1,000 grams, but the actual cup itself has a mass of 214.6. So I really need to like take that out of there so that the actual mass is 785. So now I have mass and I have volume, so I can figure out density. So I'm going to go density equals 785.4, and I'm going to divide that by 250 pi. And when I type that in, I'm going to make sure I put that in parentheses so order of operation does that correctly. And sure enough, I get 1.00000. Isn't that fun? I just proved the density of water is 1. Fun on my Saturday night, folks. We're going to skip over number 3. I'll put it on the answer key in case you want to look at it. She's an animal. She finds a treasure chest packed with metal coins. Good for her. The chest is a rectangular prism with dimensions of 50 centimeters, 50 centimeters, and 1 meter. Uh-oh. The coins have a combined mass of 4,825 kilograms. Hoping to find gold, Cassandra calculated the density to determine the metal of the coins. What kind of metal are the coins made of? So we're looking to see if they're bronze, silver, lead, or gold. Now listen, you got to pay attention to these units, folks. Look over here. These are kilograms. Excellent. I got some kilograms. But in the end, it's in meters. Now look at that's 50 centimeters, and 1 meter. So those centimeters need to get converted to meters. All right, now if you don't know, meters is 0.5 meters. So I'm basically taking 0.5 times 0.5 times 1, which is 0.25, and now that's meters cubed. Okay, that's my volume of the rectangular prism. So now I'm going to do density is mass divided by volume. I've got 4,825 divided by my volume, which is 0.25, and I've got a density of 19,300. And sure enough, that would be gold, folks. That's kind of fun. Okay, now we'll skip over 5. I'll put that on the sheet for you too. And if you go down, oh, darn, I did it again. Okay, if we go down here, whoop, too far. We're going to do some population density, which is very important at this time because no area should be highly densely populated during our COVID crisis. So what we need is to know what population density is, which is basically just the number of people per unit of area. For example, today I went to the state park to do my run, and it was mobbed, and we could not stay 6 feet apart, even though I was running in the woods on the trails. So I will not be going back there because I want to stay healthy. I guess I'm forced to run back on my roads here. Okay, so during an experiment, the same type of bacteria is grown into 2 petri dishes. Petri dish A has a diameter of 51 millimeters and approximately 40,000 bacteria after an hour. Petri dish B has a diameter of 75 millimeters and approximately 72,000 bacteria after an hour. Determine and state which Petri dish has a greater population density of bacteria at the end of the first hour. Okay, so I like to do this. I like to take, and I know I need to find the area. So I know area is pi r squared, right? Because I'm working with a circle. That's what my Petri dish is. All right, so my radius is 50, my diameter is 51, so that means my radius is 25.5, right? And I'm going to square that, and then I'm going to times it by pi. And when I do, I get around like, I don't know, 204282, blah, 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 6. I don't know, there's some other numbers there. This might be 0.8. I can't even read my writing, and it's Saturday night and I'm exhausted. Okay, so then I'm going to look at the area of this guy over here. So if I look at the area of this guy over here, I've got pi r squared again. And my radius on this, the diameter is 75. So now my radius is 37.5 squared times pi, which gives me around 1406.25 pi. Okay, now when I take those areas and divide them out by the population, I end up getting around 19.58 something here. And this guy gives me around 16.2974. So even though this dish is bigger and actually has like a higher population, this one over here, A, is more densely populated. It's smaller and there's quite fairly a large number of bacteria in that space. So A has more. Okay, now it wants to know what the units are. Well, that's kind of fun. So the units are basically the bacteria, right, divided by millimeters squared. Because our units were in millimeters there, and here comes the family in the house. So they're going to be in millimeters squared because it's area, it's not volume. And that's our population density. All right, I hope you guys have a great day, and I'll see you later. Bye.